Okay, welcome back, everybody. I wanted to go over some supplemental material that I didn't include in my original talk just because it made it a bit too long and it was a little bit off topic. So, a couple of things that I wanted to go over was how I captured the instruments that I did and how I generated the spectrum graphs that I showed you guys. You also might be interested in hearing what the sounds were that I actually captured and taking a look at how the spectrum evolved over time. So let's get into all of that. Experiment and see what I came up with. So I have a very modest home recording studio that I've just set up in the last month or so. And so what I did is I use an entry-level microphone. It's a cardioid condenser mic. I turned the high-pass filter on. I'm in a little bit of a noisy environment, so that kind of helped limit some of the noise or the house creaking or whatever else was going on. And I routed that through my interface using balanced XLR cables into GarageBand, and then I used the Spectrum EQ tool in GarageBand to observe the frequency analysis. So let me switch to GarageBand and I'll show you kind of what I captured and what the results were that I got. So here we are in GarageBand, and I'm going to start out with the tuning fork here. And what I'm going to show you, you can click on this and you can click on the visual EQ, and then if you have the analyzer checked here, it'll kind of show you what's going on. So let's see if this works. If I play this, everything else muted. So you can see that's the tuning fork, and again, it has very little spectral power in any other location except for that kind of fundamental frequency. So that was kind of as I expected, you know, much like a sine wave. So here's the singing bowl. This one was kind of interesting. So let me play that for you and show you what I saw there. So if you're not familiar with this instrument, it can be played by either striking it or kind of stroking it, exciting it with a rubber mallet. It's very similar in concept to if you've ever taken a wine glass and rubbed your finger on the edge of the wine glass to get it to resonate. And so you can see it was fairly limited in its spectral complexity when it's resonating kind of at this frequency. I mean, there are some, you know, partials, overtones that are coming up, but most of the spectral power is located just in that fundamental tone. So we'll go to the piano. Take a look at that one real quickly. Oops. Okay, let's try that again. So this actually was a little bit surprising to me. It turns out that a piano is fairly complex spectrally from the spectral analysis point of view, as you can see with all those kind of partials, those higher frequency partials that are showing up in the graph there. And quite a few of those are inharmonic, so that was a little bit surprising to me. I kind of expected everything to be more simply just those, you know, harmonic overtones, and it turns out that a piano is fairly complex. Actually, I'll tell you what I'm going to do. I'm going to do the guitar next. Let's take a look at what we got with the guitar. So So again, there's a lot going on there. It seems like there's a lot of other energy besides just what's going on in the fundamentals. So again, maybe some inharmonics. It's a little bit more difficult to tell with the guitar, or at least the way I recorded it, captured it there. So let's look at the clarinet next. So here you can really clearly see all that higher frequency component of the clarinet. So there are some, harmonics going on there, and then it's really difficult to tell with this particular view. Are those all harmonics or some of those inharmonics? But kind of a very clear definition of what the frequencies are there. Finally, let's look at the saxophone real quickly. So similar to the clarinet, definitely the harmonics are there. I'm speculating that many of those are not integer multiples of the fundamental frequency, so I'm speculating that there's quite a few inharmonics there. So that kind of gives you an idea of what I did to just kind of test out my studio. And so in conclusion, the tuning fork and the bowl did have lower complexity from a spectral analysis point of view than the other oscillators, which is kind of what I expected. Looking at the overtones in GarageBand like this was not as clean and neat as I kind of expected. I was hoping to be able to identify harmonic versus inharmonic overtones or energy, and I was not as easy to do that. And I was surprised at the complexity of even the stringed instruments that I used. So all in all, timbre is pretty complex, and this is the reason why even when different instruments play the same pitch, they sound different. So I hope you enjoyed this lesson. Thanks a lot.